All right, here's the next long division video. With this one, we still have divisors that are in the teen range, but our quotient here is going to be bigger numbers. So 465, 1, 2, 3, 400, 6 tens, and 5 ones, okay? And we want to divide that by 15. How many 15s are in 465? Or if I make a rectangle out of 465 and 15 is one side, tell me the other side. So the first thing I see that I can do is I can take this 100 and 5 tens from here, and I'm going to go 1, 2, 3, 4, 5. So I've used up this 100 and I've used up 5 tens from here. I still have 5 left. 1, 2, 3, 4, 5. They can go right there. And I can put this 100 right there. So now I've used up 3 hundreds. 100, 200, and 50 and 50. Okay? And I still have another 100 and I do have 5 more tens, so I can do it again. 100. 1, 2, 3, 4, 5 tens. Okay, so I've used up that, and I have used up 5 of those. I still have a 10 and 5 ones left. So I have 15 on that side. What do I have here? How far have I gone across? I've gone across 1, 2, 3 tens. I've gone across 30. So I'm going to put a 3 in the tens place because that's how far I've gone across. So how much did I take away from my original 465 that was down here? I took away 30 times 15, and that would be 450. And so what do I have left? I have 15 left, 10 and a 5. So now I need to make a rectangle with 15 on one side and something else on the other, and hopefully that's pretty obvious. 1, 2, 3, 4, 5. 15 on one side and just 1 on the other. So put my 1 here because I've gone across 1 more. And so how much did I use up down here? How much did I take away from my 15? I took away 15 times 1. Or up here, 15 times 1. That's 15. And now I have nothing left down here, no remainder. So I have made a rectangle out of 465. On one side is 15, right here. And the other side, I found out, is 31. 306 divided by 18. So I want to make a rectangle with 18 on one side. So I know I can use 180 out of there. So I will do 100. 1, 2, 3, 4, 5, 6, 7, 8. So I've used up that. And I've used up 8 of these. So I have 2 tens left. And so can I do it again? Can I do another 180? No, I don't have enough. So I'll label that. I have made a rectangle with 18 on one side, and I've gone across the other side 10, 110. So how much did I take away from my 306 that I started out with? I took away 18 times 10, which is 180, or over here, 18 times 10, 180. And what do I have left? 126. 126, or you could subtract the traditional way from right to left there. Okay, so 126, and I need to make that into a rectangle with 18 on one side, and I have to go across the other side a certain amount that I don't know yet. So here's where I am going to start guessing, problem solving, estimating, whatever you want to call it. So first I'm going to trade my 100 for 10 tens. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so I still have 126 here. And I'm going to start guessing. Let's just 1, 2, 3, 4, 5. Let's just take away these 5. Okay. So if I use up 5 tens, to fill in the rest of the rectangle, I need 5 times 8. So the rest of this, to fill this in, would be 5 times 8, which is 40. Do I have 40 left here? No, I have more than 40 left. So let's try, you know what, we have a lot left, so let's try 2 more tens. Okay, so I have used up 7 tens. These 5, those 2. And to fill in the rest of my rectangle, I need 7 times 8, which is 56. Do I have 56? Oh, look there, 50 and 6. I do. So I'm going to not draw 56 dots because that would take me forever. I'll just write 56 in there. And so I've used up my 56. And so I've gone across 7. And you can look down here. 1, 2, 3, 4, 5, 6, 7 is what we've gone across here. So I had 126 left down here. And I made a rectangle with 18 on one side. And I went across the other side 7. So I'll put a 7 in the ones place. Okay, so how much did I take away from my 126? I took away 18 times 7, or 18 times 7, and that is just 126. So we have no remainder left over there. Okay, this problem is 532 divided by 14. So I have 5 hundreds, 3 tens, and 2 ones here. And I want to make a rectangle with 14 on one side. So first thing I am going to do is use up this 100. And 1, 2, 3, 4 tens. And you know what? I just see that I can go 5, 6, 7, 8 tens, and 9, 10. So here's another 100. And I have to fill in another 100 here. And another 100 here. And I still need to fill in 2 tens here. I'll cross those out. And can I do it again? I do have another 100, but do I have 4 more tens? No, I only have 1 more 10. So let me make this a little bit neater. Okay, so I have gone across as many tens as I can go across. So I have 14 on that side, and I have gone across 10, 20, 30. 30, or 3 tens. So I've gone across 3 tens. I'm going to write that there. So how much did I take away? I took away 14 times 30, which we can see down here, 420 is what we used. Or you can do it with Cuisenaire rods or do it the traditional way, 14 times 30, such like that. Okay, so 14 times 30, 420. So that's how much we took away and put over there. So what do we have left? We have 112. 112, and you could do it right to left if you really want to. So now, 112, I want to make a rectangle with 14 on one side and figure out what the other side is going to be. So first thing I'm going to do is break this into 10 tens. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And here's where the problem solving, guessing, estimating comes in. I will try 1, 2, 3, 4, how about 5? Use up 5 of those. Okay, so to fill this rectangle in, I would need 5 times 4, which is 20. Ooh, I have a lot more than 20 left. So let's try 2 more. So now I have gone across 7 and up 4. So 7 times 4 is 28. Nope, I have more than 28 here. So let's try another one. So now I've gone across 8 and up 4, and that's 32 to fill this in. Do I have 32? Yes, I do. 3 10s, and 2 1s. So this is very disproportionate. So just kind of got to imagine that it looks right. So 32, I filled in using this stuff right here. So I have a rectangle 14 up, and across I have gone 1, 2, 3, 4, 5, 6, 7, 8. Gone across 8. And so I can write my 8 over here. And so how much did I take away from my 112? I took away 14 times 8. See the 14 times the 8? And that is 112. So nothing left. All right, last one, 759. 750 and 9 divided by 11. So we want to make a rectangle with 11 on one side, and I can start doing this. There's 11 on this side, 10 and 1. So I've used up 100, and I've used up this little guy right here. And I can do it again. I've used up 100, and I've used up this little guy. And again, I've used up 100, and this 10. And again, I've used up 100, and that 10. And again, I've used up that 100, and that 10. Okay, now I see I still have another 100, and there is a 10 in here. So I've used up that 100, and I'm going to use 110 out of this 100, which means I have 90 left. 1, 2, 3, 4, 5, 6, 7, 8, 9. So I have 99 left. First, I'm going to say, how many have I gone across? Well, I've gone across 1, 2, 3, 4, 5, 6 tens, or 60. Up here, I'm going to write 6 in the tens place, because that's how far I've gone across my rectangle. And so how much have I used up? I have used up 11 times 60, or that would be 660. And what do I have left over? 99 left over. Okay, now this, at this point, this should be pretty easy, because how do we make a rectangle with 11 on one side where the whole thing is 99? Well, we do 1, 2, 3, 4, 5, 6, 7, 8, 9. We use up all those. 1, 2, 3, 4, 5, 6, 7, 8, 9. We use up all those. So 11 times 9 is 99. So we've gone across 9 more. And so how much did we use up out of our 99? We used up 11 times 9, or here you can say 11 times 9. We used up 99, so I'll get kind of smushed in here. And we have nothing left. 99 minus 99 is 0. So we have a really big rectangle with 11 on one side and 69 across the other. 69. And the whole amount is 759. So we've taken 700s, 5 10s, and 9, and we've changed its shape into a rectangle that looks a little different, but it's the same amount, the same quantity as what we originally started with. And so our answer is 69.